Section 2, Unit 2, Section 3.4, Worked Examples. Use a truth table to determine whether the two statements are equivalent. And in the homework, they're only going to ask you to put in the final decision column for each of the compound statements to determine if they're equivalent or not. I went ahead and built a truth table for each compound statement. So the first one is shown here. And we're going to go ahead and start with column 1, which is the not P's, and compare that to, it actually should be a 2 here, column 2, and they're not Q's. And we notice that it's a conditional, and we're looking for a true to a false, which is going to give us a false, which is case 3, and everything else is true. And then we've got another set of parentheses, column 4, not Q's, I've moved over, in column 5, the not P's, and another conditional where we're comparing. And again, we're looking for a true to a false, which we see here. In case 2, everything else is true. And now I'm going to cross out the columns that I'm no longer working with to make it a little bit easier for me to see where I'm comparing now. So I'm comparing 3 with 6. And the connective here is an and so what I'm looking for is 2 truths, and I see that in the first case and in the last case. And the middle 2 cases are going to be false. All right, and then let's go down on the second compound statement and make the truth table for that one. This one's a little bit easier. We've got not P if and only if not Q. And for a biconditional, it's going to be true when both simple statements have the same truth value, which we see in the first case and in the last case. And the middle 2 cases are false. And again, if I compare this column 7 up here with the column 3 down here, I see that they're identical, so therefore these statements are equivalent. And again, in my math lab homework, I would be adding to column 7 here and then column 3 from the second truth table as the answer columns. Use De Morgan's law to determine whether the two statements are equivalent. So I've got a conditional statement, and I don't need to worry about the consequent because they're both are. I need to worry about the left portion, the antecedent. And so I'm going to go ahead and use one of De Morgan's laws on the left-hand side compound statement. And I'm going to use De Morgan's law shown here, and I'm going to use that for that antecedent over there, the not parenthesis P and not, I'm sorry, Q and not P. And I'm going to see what happens when I go ahead and apply that De Morgan's law, and I notice that I get this compound statement here, which is not equivalent to the one given in the problem, so therefore these two statements are not equivalent. Use De Morgan's laws to write an equivalent statement for the given sentence. It is false that he does not want to smile or he is mad. So I can use this De Morgan's law right here. I write that compound statement symbolically right here. And then I can use that one De Morgan's law to find an equivalent statement, which would be he does not want to smile and he is not mad, which was the first choice right here. Okay, now we're going to write the converse, inverse, and contrapositive of the statement. If you vacuum the rug, then you can play video games. Remember, in the converse, the two simple statements are reversed in the conditional statement. So the converse is going to be, if you play video games, you can vacuum the rug. If you play video games, you can vacuum the rug. That's choice B. And then the inverse negates both of the simple statements but keeps them in the same order. So if you cannot vacuum the rug, then you cannot play video games. And that one is choice D. And then the contrapositive flips both simple statements and negates both of them. So if you cannot play video games, then you cannot vacuum the rug, and that is choice C. In the final problem, they've given us 3 compound statements, and they want us to determine which are equivalent. And they're telling you to use information about conditional statements like converse, inverse, contrapositive, De Morgan's laws, the fact here that we can translate a conditional to a equivalent statement. And so what I did first was I picked my simple statements. P is the bus is late, and Q is I am in class on time. And I wrote the 3 simple statements, A, B, and C, symbolically. And the first thing I did was work on comparing B with C, and I use the statement, the fact that I can rewrite this conditional in this format here. And if I go ahead and replace the P and the Q here, the P with a Q, as I see in choice B, and the Q with a not P, and write the equivalent statement, indeed, B and C are equivalent. So I've got that part of it. Now, I only need to now compare A to either B or C. And I went ahead and actually built a truth table showing all three statements. And you'll notice when you do that truth table for compound statement A, the final column is true, false, false, false. And that's not the same as what you get for compound statements B and C, which have the same truth values, which is what we already showed. And so therefore, the correct answer on this one is going to be B and C. And you have a lot of possibilities here. Sometimes you can use the conditional and contrapositive. I don't see where that would help me because I only have one conditional statement. If I had two, I might try to see whether or not I could say they were equivalent, because I know that the conditional and the contrapositive are equivalent and the inverse and the converse are equivalent. But in this case, I didn't have that, so I had to use some of my other options in order to show equivalency. And if I can't use any of the other things I know, I can always build a truth table.